So tonight we're going to talk about monoliths and microservices. It's a Ruby event, so it's going to be about Ruby and Rails. Basically, is the theme of the evening. Here's the plan, or what I was planning to talk about. First, we go through some intro and definitions to the topic. Then a section on picking the right battle. This is all about sort of what questions to ask, what things you need answered maybe before you make your decision on how to move forward. Third, it may or may not be a popular or unpopular decision, but I'm going to talk about choosing a monolith first and maybe some of the reasons why you might do that. And we'll go more into that after. And then talk about the transition to microservices and what that might be. So, ¿quién soy? That's Spanish for who am I? I do speak Spanish. I lived a little bit in Ecuador and Colombia, where my wife's from Colombia, so we lived there for a little while. And we live in Toronto, and we just bought a home in Rockwood, so we'll be moving out to the Guelph area when they finish building this thing, which is going to be about a year from now. So I work remotely for a company based in New York called Regali. They're a fintech company that works sort of to help immigrants living in the U.S. who still support their family back home, mostly in Mexico and Dominican Republic. And basically it's a bill pay application. So instead of sending money every month, which has many issues I've heard, you can pay your family's bills while living in the U.S. so that they don't have to worry about that. So that's sort of what I do, mostly in Ruby and Rails. And I also do a little bit of writing for the CodeShip blog. For about a year now, I write one article a month for them, also about Ruby and Rails for the most part. So the monolith, that's where we're going to start. A little subtitle, majestic or otherwise. Anyone know who DHH is? He always talks about the majestic monolith. It's sort of, I guess he hates the negative stereotype that monolith apps are getting, so he wants to call it, his is majestic. So what is a monolith? A monolith, I would say, and people may have different definitions, is a single Rails app, or one large Rails app that tends to handle many different parts of your business. So take a company that maybe does e-commerce. It's going to handle the storefront, plus the maybe checkout, plus the shipping and the back end. Sort of one app that handles everything all inside of a single Rails app. And maybe what you would say the opposite of that is microservices, where you either start with a monolith and break it up, or you start from the beginning and you come up with smaller apps. Could be Rails, could be something more lightweight, could be a different language, it doesn't really matter. And you try to make them as sort of direct as possible. They handle one thing, and that's all they worry themselves about. And you're going to have more than one of them, so your business or your app is essentially multiple small services communicating with each other. And whether that be over HTTP with JSON or through some sort of queuing system, I'd say there's sort of different ways you can have them communicate. Most commonly, probably just HTTP, JSON APIs. For the last couple of months, I've been sort of thinking about this talk, preparing for the conference. So every time I saw somebody I know like tweet about it, I just screen capture that. So mostly, so I would have some quotes to put in this thing. So Sean Griffin, who he does some Rails core work. I think he does Active Record mostly for Shopify. He wrote, "When did monolith and microservices become the only two options? Pretty sure there's a spectrum in between." So there's no black and white. You may have a large Rails app that does 75%, and then a few smaller ones that handle more specialized functionality. for whatever reason you choose to break off. But there's no sort of, or you may have a few medium-sized apps that work together. There's no like hard and fast rule, no law against this stuff. And another guy who I don't know, but by microservice, do you really mean smaller monolith? And I'll just leave that. So here's 4 wildly, well, I would say wildly successful companies, websites that everybody knows about. This is WhatsApp on the bottom. And does anyone know or throw out some things about them that may cause them to be similar or different from each other? Anything?
They all have databases.
They all have databases, sure.
User content.
Yep, user content.
They can all get spiky traffic.
Yep, yep. They're massive, they are popular, successful. And all of them have a different core language that powers them. From what I never worked there, just like reading. Etsy, from what I've read, is in PHP. Reddit, I believe, is an open source Python project. Shopify is mostly a large Rails app. And WhatsApp is Erlang. I'm not sure if anyone's worked with Erlang, but Elixir is becoming pretty popular in the Ruby community, which is built on top of Erlang, the VM. And basically by that slide, I wanted to show that we're talking about this and it's important to us as developers, but technology is not the main determinant of success. All of those companies are successful using languages maybe people think are passé, or no, I wouldn't want to program in that language or whatever. And it just goes to show that the important thing isn't the technology, it's the idea and sort of the thought that goes into the project, and those things are more important than the technology you choose. And the same goes between monoliths and microservices. Some people will say like, oh, you can't scale with monoliths. There's some pretty big companies that have figured out, the middle one on the left is Basecamp, GitHub and Shopify. They're, from what I've read, are pretty much monolithic. I guess in this case, Rails apps, all of them. And then you have on the other side microservices. So that's Netflix. I believe they're pretty sort of small microservices. Uber is the one below. I read one thing that they have like 500 or 600 microservices for 1,200 developers. So basically one for every 2 developers. To me, that's like mind-boggling. I don't even know what they could possibly be doing, but and Groupon as well. They actually have some articles about taking their monolith and splitting it into microservices. But all that to say, it obviously doesn't determine success. So by making a decision, you're not going to ruin or set up your business for ultimate success, basically. So that being said, which might you choose? I think this talk is mostly for when you're thinking about starting a new app, but maybe you have an existing one and it can shed some light in terms of where you can take it. I think technology questions at this point aren't even the most important questions. Some of the important questions before you even think about how am I going to architect my app are what problems are we solving? Understand sort of what you're trying to do very well. What are the technical challenges? And I would say when you're starting, pretty much they're impossible to know. There are things that you're going to discover along the way. Making a business, you maybe 6 months out, could be a couple years out, you truly understand. Some of them you won't even realize until you reach a certain scale, or so those are important to know, but I don't think you necessarily know them at the beginning. The third thing are, what are our domains? And how I would define a domain is by comparing it to maybe a large corporation, how they have different departments within it. They have an HR department, accounting, IT, marketing, business, sort of all of those different sections, and they all handle one thing for the business. So when we think about a website, it's figuring out what are our domains. So if we're like a warehouse management company, and one of our domains may be all things to do with like where in the warehouse can we put these boxes, spatial like storage issues. Another thing may be labels, like a whole section on labels and tracking and whatnot. And to be honest, this isn't something that you really have clear at the beginning, I would say especially around where are the boundaries. So how does one domain of your business communicate with the other domain of your business? So later in the talk, I'm going to create a fake llama purchasing and shipping business. And we're going to talk about maybe what the domains might be in that website and how do they communicate between them. Here's Justin Searles, another sort of pretty popular Ruby speaker. The Wall Street Journal test. If your company isn't regularly discussed in the Wall Street Journal, you probably don't need a microservice architecture. Some of these are like tongue-in-cheek, but I found it funny, so. And here's a quote by DHH. And this is from his an article he wrote on the majestic monolith. And he says, there are other patterns that are less about the code and more about how the code is being written, by whom, and within which organization. And by that, he's talking about what does your organization look like? Are you a 5-person dev team, or are you an Uber or bigger with 12,000 or 1,200 developers? The solution you come up with is going to vary quite drastically between those two scenarios. And he actually, I was listening to a talk by DHH on it's called the Full Stack podcast. It's by Adam, a guy from this area, I believe. And it's really great. And he talks about companies looking up to the Facebooks and Googles of the world and saying, well, if they're successful and they do it, I should try to imitate them. And he says it's possibly a big mistake because their concerns and what they have available to them in terms of number of people, finances, expertise is going to be quite different than what we might have. Other decision factors into making this choice between sort of our architecture is, do we need different languages or technologies to do whatever we're building for? So Facebook, they are in PHP, and I believe though that one of their sort of areas that they probably do in a different language is image processing. And they may choose a different technology for that because there's something much more better suited towards processing images than PHP is. Or there could be other different technological reasons for choosing maybe main app in one language, service in a different language, but it's up to sort of us as developers to figure out what those might be. Security and compliance. I've heard Stripe, everyone knows Stripe. They're awesome and easy for doing payments, but I've heard them described more in terms of their compliance as a service. By using them, you don't have to worry about PCI and all of that stuff. And there may be sort of security concerns for our own apps that certain parts of our data may need to live in different areas and have different rules around its access and availability. And that may also cause you to have different services that deal with that. And I would say the most important thing is the experience or expertise of the team. If you have 5 developers who have never built a microservices architecture before, maybe they don't have a lot of DevOps experience, it may not be the right team to tackle that challenge. And probably they're a lot better suited, and I definitely fall into this category. I'm not great at DevOps and that sort of whole world. And so it's about choosing something that fits the team that you have available. Like, why would you choose .NET if you're all Ruby developers, sort of thing? you're setting yourself up for potential challenges. So after asking all those questions, I'm going to advocate, and this is purely based on my experience. Other people here may have different expertise or experience, and maybe you may have come to the opposite answer, and that's fine. There's no sort of right or wrong approach in programming most of the time. And I'm going to say that it's a great idea to start with a monolith. And I'll talk about some of the reasons that I think that. I mentioned at the beginning, when you're starting out, what's important is to understand domains, boundaries, and challenges that you're going to run into as a company, as a website. And often you don't know what those are. So by sort of building it in a single place, it gives you a little bit more, I would say, flexibility to move things around and really define what are our domains and what are the boundaries between them. What sort of needs to flow from one to the other and how are they set up. It's a much costlier mistake if you break them out at the beginning and you discover that you've modeled your domain incorrectly than if you have it all in one place, I would say. But even with a monolith, I would say the key is to focus on writing organized and disciplined software. And that's what we're going to talk about a little bit later when I show an example of that. And it's not probably the only way to do it, but it's one that I think works pretty well. The last approach is to break off services as necessary. And I have in brackets or don't. If your business is working fine, you're not running into sort of issues that demand it, why? Like, I think you should have a good reason for making any decision on the website that you're working on. So, I think I talked about this already. Maybe I'll just go in a little bit deeper. Talk about the first one, boundary mistakes are lower in a monolith. I would say lower complexity, and this may be controversial, but the reason I say that is because even if you have microservices, all of them together need to still accomplish the same thing as your one monolith, except, so each service may be simpler, but the system as a whole that needs to communicate and share data, I would say it becomes more complicated as a whole in a microservices setup. Also at the beginning, there's less things needed, less infrastructure, less servers to deploy on. The dev environment, I would say, is a little bit easier. Where I work now, we have a few different apps, and we haven't yet sort of set up Docker or Vagrant files for them. So if you want to sort of test the system as a whole, you have to like spin up 3 Rails apps, and it's a huge issue for new developers. When I worked at The Score, it was a big enough company and we had the expertise that we actually did have a Vagrant box that you sort of downloaded, and it contained like running versions of the services that we would need. But that's a lot of work, and you need someone that sort of can maintain that and has that expertise. Coordination is the last thing. I've also seen it quite challenging. Say 2 different teams are working on a deploy, and they're both sort of, they rely on each other. So you either try to like deploy them at the same time, or you have to work on versioning them so that you can deploy one first and it can handle traffic from version 1 and 2. And it can just get a little bit tricky. I'm sure there's good ways of solving that, but it's just something else to think about. All right. So here's the part of the talk where we're going to work through some code examples. And the business that I fake invented is called Alpaca Llama. It's a play on I will pack a llama, because it's a llama shipping. You buy the llama and then we ship it to you. So because it's fake, I could hide a lot of the complexity that's in a sort of real e-commerce website. But I wanted to show 6 models that I came up with that we may need and talk about how they're related. So we obviously have the llamas. That's the thing we're selling. It's the product. We have customers who are going to be buying these llamas. And they're sort of connected through the order. So a customer places an order for one or more llamas. And then once the order's been placed and paid for, the llama is shipped. So I've modeled that separately as a shipment model, and that links up to a carrier, Curelet, FedEx, whoever's sort of handling the shipment. And another model that handles tracking, sort of following it along on its journey and all of those things. I'm gonna go to this one slide first. I call this the model walk. Maybe there's a real name for it, or like the walk of shame. But part of the great thing about Rails, but also where you can start to run into huge challenges, is that it's so easy to walk from like one model through the entire website. Like you can just, here I found the last tracking record, then I went to its shipment, then its order, then its customer, to get to the customer name. And
You're looking for law of Demeter.
that's the official term, yeah, law of Demeter or Demeter.
Probably saying it wrong.
Probably the same. And basically, you should be talking to your friends, not their friends. Sort of only go one level and don't step through the whole system. But I only show this because in a Rails app, it's very easy to fall into this trap because of how easy it is. You can easily slap a has many belongs to onto your models, and boom, you can step through the entire system. And I love it for like, I need to go into the Rails console and just find some data, which is ... But by writing code that, maybe it's not this sort of intense, but by writing code that maybe steps beyond its bounds, it becomes harder to break things apart going forward. So I'll just step back one slide. So if we take our system with its 6 models, we may come up with what are the different domains of our website, our Alpaca Llama website. So I came up with, I had sort of the purchase or the e-commerce, the front of the website where customers come in, they find the llama that they like, and they place an order for it. And then I've also come up with a shipping domain. So those are things that only have to do with shipments, the tracking, who's the carrier, label printing, sort of cost estimation, anything that has to do with shipping. And I've put them into 2 separate, what I call domains. And the yellow line between them is sort of how they communicate from one domain to the other. Sort of where the connections need to be to accomplish what our website needs to do. Anyone watch Game of Thrones, or at least have seen an episode of it? This is the wall, what's it called? Yeah, the wall, right? Yeah. Which separates the north from the south, I guess. And you'll see that it's a massive wall, but there's a little gate, and only a few things are passing from one side to the other. So if we step back and talk about this, imagine that our 2 domains are divided by that massive wall, and we just have a little gate for things to go back and forth between one side and the other. Now keep in mind, at this point, I'm still talking about a monolith. All this is going to live within a single application. It's more about exercising constraint and discipline in terms of how one domain communicates or works with the other domain in the system. So thinking about that wall, I thought it maybe makes sense to call it a gate. And I'm sure there's technical terms for this. I suck at it, obviously, well, Demeter, but I invented my own terms. So this is a module. So modules, you can't instantiate them. They basically are a container for methods and other classes. And what I've got is this module for shipping, and it's got one method called schedule. And this is basically the tunnel from one domain to the other. So here we have this method called schedule, So we need to know, in terms of shipping, what do I need to actually make a shipment? And this is a fake website, so I'm sure it would be different if it was a real one, but I came up with, well, we need an order ID, some way to track this to the other side of the system. We need to know where it's going, an address. The weight's important because that determines how much it's going to cost to ship it. And the service level. Are you sending your llamas express, ground, sort of that type of thing? And this method here, it sort of manages the communication from one side of the wall to the other. So at this point, because it all lives in a single app, all it does is call a method on the shipment model, which we'll look at next, and that sort of handles the shipment or the shipping side of the wall's work. So it calls a method called schedule, same thing, and passes that information along. Now, you'll notice that we could have just sent this right to the shipment model, but it will hopefully become a little bit more apparent in the future why we may want to model it like this. It's not the only way to come up with things to sort of solve this issue, but it's what I came up with. So some of the rules: only pass what is needed for the job. If you don't need to pass like billing information or the name or age of the llama they bought, like things that have nothing to do with shipping, don't send that over because it's going to have it. You're duplicating your data potentially, and you're sort of exposing more than needs to be exposed. And same with what comes back. Return as little as possible. So in this case, we basically just need to know, were we able to schedule the shipment, true or false, and what's the tracking number, basically, or the a reference to that shipment. Even though they're living in the same place, treat them as if they were different code bases. You're unable to sort of jump into that side of your app. And they don't know how each other work. It's not up to the purchase side of the website to know how the shipment side schedules shipments and works with carriers and estimates weight, costs, and all of that stuff. Let the domain handle what it does. So it's a lot of code, but it's not really too important to understand all of it. I'll just talk about sort of what it's doing. So on our purchase side of the app, we have a module called purchase, and inside of it we have a class, an active record model called order. And this has a method called ship. And basically what it does is it calls schedule below, which talks to the gate between the two sides of the app. It sends over the information that's required of it. And then we receive back, was it a success or not? And sort of what are the additional details that come along with that response. So if it's a success, we can update the status of our order, we can change its status to shipped, and we can record a shipment ID, which is basically the reference from one side of the domain to the other. And if it wasn't a success, we can, in this case, we're just throwing an exception, and then however you deal with that is up to you. It's a fake app, so I can do what I want, and I'm not going to deal with it at all. So now let's go on the other side where the module shipping. It receives the call to schedule a new shipment. It creates a new record, a new active model record, and it tries to save it. If it can save, it returns true and its ID. Otherwise, it's going to return false in this case, and a hatch of errors that the active record generated. And normally we don't deal with errors like this. Like we sort of get the model back, and then we can, maybe it's shown in a form and it knows how to deal with the errors and whatnot. And I did it like this for a reason, and that's because I didn't want to return the actual object back. because that's then exposing the whole, like, you can walk through the entire model. And this is maybe more work, and maybe it's more of a pain in the ass, but it's going to set us up better in the future. And maybe these could be special objects that are passed back, I'm not sure, but in this case, that's going to return. So what's next? And as I mentioned before, maybe nothing. If our website's working well, developers are happy, we don't have any need, well, if it works, don't change it. But either I want or I need to break out this monolith. It's starting to cause problems for the team, but that's okay, because we've taken extra sort of care to separate our model, our domains, understand where the boundaries are between them, and we've drawn clean lines in the sand. There's a clear channel of communication from one domain to the other. And because of this, it's a lot easier to take our monolith and break off parts of it into their own services. So how do we go about doing that? This is just a funny quote I saw. This is your return type, int. This is your return type on microservices. IO, logger, ether, HTTP. Microservices know the risks. Nothing in life is free, or there's no free lunch. There's a lot of great things about microservices, but there's also things you should be aware of. What were simple method calls are now HTTP requests, or some sort of queue, or other way to handle the communication between two separate apps. Anytime you introduce the network, I would say you increase the chances of something going wrong. Everything doubles. You had one Rails app, now you have two. You have two databases. You have two sets of gems that you need to update when there's a bug patch or something for Rails. Sets of servers or deployment scripts or development environments. Everything doubles. And this is why I mentioned at the beginning that the expertise of a team can play a big role in choosing one or the other. If you have a really strong DevOps culture that manages the whole setup programmatically, it's easy to spin up new services and servers and dev environments or whatnot. I would say you almost need that if you're going to do a microservices approach. I mentioned coordination before, different versions, trying to coordinate releases with different parts of the system become more difficult, and local development. So how would we go about converting our single monolithic Rails app into, in this case, two different ones, because we only have two domains in this app.
Can I make a comment?
Yeah, please.
You said about the previous slide about coordination between services.
Mm-hmm.
I'm just talking from what I read and from the
sure.
experience of other folks. It looks like Netflix has big adoption of microservices. In their case, because they want to be reliable, if a service fails somewhere in the part of the world, they want to be able to run it in other parts.
Mm-hmm.
And so one of the advantages of microservice, from my understanding, is that sometimes if you design it well, you don't need to coordinate. You have this module that you can leave the rest of the system running, and you can update live the other one. Yeah.
I'd say it's possible for sure. And I've heard that Netflix, they actually have this, when they deploy to a server, they deploy two things. One's this Java app that sort of manages talking to all their different services. So the first thing about Netflix is they're massive, and they do have the expertise and developers to manage that sort of scale and number of services. But even a simple example of we want to send over a new field, or we want to remove a field, even more difficult. We have to sort of coordinate that, because if we deploy the thing that removes sending the field over first, any call is going to fail because the other service may not be prepared to handle a request that's missing a value. So we sort of have to coordinate, is this one gonna go out first? Because it can, and it will handle with or without that extra field or field we've removed. I'm sure there's great solutions for it. It's just something to think about for sure. Does anyone have any other, like, they've dealt with that or they know how to deal with that?
It's, when you're dealing with microservices, each one is an API.
Yeah.
And you have to version them. If you're adding things to the API, it's usually not a problem. As long as you have reasonable defaults in your API, or you just don't care, you're just starting to collect the information. But otherwise, you've got to version it if you want to remove a field or if you want to change it. So they're all just, it just increases the number of APIs you need to handle in your head.
Yeah, so when I was working at the Score, I was working on the backend team, the API team that sort of provided all of the sports information for the Android and iOS apps. And we had to deal with tons of different versions. And the code got messier. There were if statements, there were subclasses, there were just different paths through the code for dealing with different versions. And our test suite would actually, we had like an array of versions, and it would run and like loop through the versions, and it would record the responses of each version. So you'd end up with like 10 different JSON files for each endpoint. Like all, it is something to think about.
So would that mean you could make a change in the code and like break version 3 and version 7, but everything else was okay?
Correct. So this way we would know which, and mobile development's a bit different because you can't sort of force your users to upgrade their clients. If they're two backend services, you do have a lot more control over that. So you don't need to deal with 10 different versions, maybe just 2. But for a large company, even a few minutes of downtime can be quite costly, so coordination becomes important. So we created a new Rails app, everything that goes along with that. We've defined our routes, our endpoints, controllers to deal with that traffic. We pick up our code from the, in this case, the shipping module and bring it over to the new Rails app. Sort of everything, tests, models, fixtures, factories, whatever you have related to that. Data also needs to be migrated. I would advise against trying to run 2 services on the same database. A few places I've worked, we've tried that. Mostly around like, we have a Rails app which is an API and another Rails app which is like an admin to manage the data. But you run into issues of keeping the schemas in sync, and you don't want to duplicate your models. So we had a gem that would contain the models. It's just, I would recommend if you're going to do microservices, try to keep your data separate. And then we need to define requests, responses of endpoints. So what were method calls now need to become incoming JSON or sort of form posts and outgoing JSON requests or JSON responses. And then we need to go back to our original app and update that sort of gate code that talked from one side of the system to the other. And what were method calls need to become HTTP requests. So formatting the requests, dealing with the JSON responses, the different HTTP error codes that could go wrong, potentially things like authentication and whatnot as well. So the gate changes. This is the middle part that handles the communication from one side of the system to the other. I've still kept a shipping module in my original app, and we still have the same interface to this, the sort of method definition for the schedule method, except now it's not just calling an active record model. I've got this new class that handles making the API request, and then another class which isn't really seen here but handles the response that provides. And that had the response class. I created a few methods to let me know, was it a successful call? Were there HTTP errors or whatnot? And then we sort of return the same thing. We either return the shipment ID, the reference, and then the errors. So the reason in the first version, where I sort of converted the active model errors to a hash, is sort of to set us up in the future, because when we're talking over JSON and HTTP, the errors that come back are going to be in a hash or an array or something like that. So it's to sort of like prepare us for not having nice models to work with. Or we create another class to wrap these errors, but it's something we have to do. So this is the original purchase order class. And what have we had to change here? The answer is nothing, because it never communicated directly to the other side of the system. It always went through sort of a channel. And it was the channel where you had to change, but everything that lived on one side of the domain stayed the same. Everything that lived on the other side of the domain stayed the same. It was just the communication part in the middle that had to change. So, testing. So we've got one Rails app at the beginning. Eventually we have microservice 2 talking together. How can we go about testing those? And I'd say there's 2 approaches in terms of testing that middle part, the communication from one side to the other. The first approach is to use mocks. Mock what isn't yours. Let it deal with its implementation and we'll trust that it does it right. It's got its own set of tests and whatnot. We're just going to mock the response for maybe the good scenario and the bad scenario. And then we can assume that given the good or bad response, we know how to deal with it. Or you can use something like VCR. Has anyone ever used that in Rails development? Yeah. So for anyone who hasn't, basically what it does is it makes the real HTTP request once, and it records that response, the request and response of it. And then the next time you run your tests, it uses that pre-recorded HTTP request instead of having to make the real one. So that's another way you could sort of do it. Make it talk once and then record it and let it go with that. Code sharing. So if I actually go back a couple slides to this one here. So we have the gate that handles communication between services. And inside it may have a few classes that handle building the requests, handling the responses. Sorry, question. You may end up with, you have multiple apps that need to do this same sort of communication between services. So one approach would be to take this middle code and gemify it. Probably it's not a gem you want to publicly release, because it would make no sense to anyone else. They're not going to use your llama shipment service unless they have their own llama business. But so we've done that in a couple places I've worked. We've sort of gemified internal code to allow us to share it across projects. And you can even just have it like you can have your own gem server, or you can just do sort of GitHub private repos, and there's like a private deploy key that you can use to fetch internal gems. And that is my presentation. Thank you very much. And I actually built like a somewhat, there's no interface, but there's like models with tests. And so if you want to check them out, I can send this to Ben or Andrew after, maybe the PDF of this. And I have links to the Alpaca Llama app as a monolith. And then I split it apart into 2 separate, basically one for shipping, one for purchase. And I've got not all the tests, but some of the tests that handle testing each side on its own. So if you want to sort of look into maybe what that request class was that I had or what the response one looks like, they'll be available in my page. Yeah. Thank you very much.
So out of curiosity, what have you used for your web mock testing? Did you use VCR your final choice? Or?
That's what I've ended up using, yeah. I've done a combo of just mocking it out or VCR. Where I work now, I was mentioning before, but we're sort of, has anyone used Mint? Like, you log in and it pulls down all the info of your, like, different bank accounts and whatnot. I'm doing something similar to that. And what we're trying to do is we're trying to reverse engineer the Android app so we can use their API that they use internally for the bank or whatever, rather than scraping their website. Because it's instead of 2 seconds, or instead of 30 or 40 seconds, it takes like 2 seconds to finish, and it doesn't break every time they update their HTML. But so we're doing all these integrations with different APIs, and each time we run the test, I don't want to log into some coworker's bank account and the balance changes, so the tests never work. So I did end up using VCR for a lot of those. Record the HTTP traffic, go through and strip out all of the sensitive information, like remove their credit card number
Your coworkers
from the repository, and it's pretty good. I like it, but can be somewhat. I mean, I don't think there's another option, or maybe there's not that many options, but what can happen is your tests work and you're happy because they've been running against a version of the API that doesn't actually exist anymore, because that company's gone and changed their API, but because you're never using the real API, you don't realize until you have other monitoring in place or whatnot. So that's something to watch out for, I guess.
I guess it's sort of similar to using mocks in any other place in the code. It makes it all the more important to have like an integration layer that even just does basic smoke test kind of stuff to make sure that the API that you're talking about has gone away, changed completely.
Yeah, for sure. Has anyone else had experience doing this sort of like mocking or VCR or things like that? Other solutions?
We use VCR.
You do? Yeah. How has your experience been?
Sometimes you need to record new episodes because if you get for some reason, sometimes it throw random errors, so you have to record a new episode.
Yeah.
I find it sometimes to be annoying, but that's the way it is.
Yeah, for sure. For sure. I've doing these tests. So for these ones here, some of them I skipped because I didn't want to spend my entire weekend writing a fake mail. But I did test scheduling a shipment. So this one here, I did make a real request with a success and a failure. And I've used VCR for this. So if you want to get an example of how this might look, you can look to this repo. And the way VCR works, it normally, you set up some sort of cassettes, like VCR cassettes, and it records them as a YAML file of all of the headers and different parts of the HTTP request and what the response looks like. So you can actually come in here, and this is what we do with like the banking apps. We hide sensitive information and replace passwords and all of that stuff to do our best to not commit that into the repository. So check this out if you're interested in how it works.
Did you use domain-driven design to define the boundaries?
Not exactly, but I guess it sort of does follow that model and approach. I haven't read that famous domain-driven design book. It's hard to get through, but I've sort of reading through other things and just development over the years. I think I use some of the principles without following it to the letter of the law. anyone who is super familiar with domain-driven design, is this approach similar or not really?
From what I read, it is.
Yeah. And I think there's probably, you may look at this code, certain parts of it and thought, oh, I might have put that in its own class, not right in the order model. Like maybe you have a order shipping class that handles like, it's up to you, sort of where you want to organize your code and whatnot. But I just put it here.
There is a talk by Martin Fowler about microservices. And first of all, he at the end says that he prefers to start with monolith and then split it to microservices because it's easy to define the boundaries, because at the beginning, even if you use domain-driven design, it's kind of challenging depending on the size of the project. Challenging to define the boundaries. Yeah, so it is easy to write the monolith first and then split.
I would also say that if you're working on a smaller team and you do use microservices and you find yourself on a daily basis having to step into multiple different Rails apps, that can also become challenging because you're trying to keep the context of like 2 to 3 different Rails apps and how they communicate in your head. I'd say even you think of Uber, 600 microservices somehow, but they have 1,200 developers, so I mean it's still a crazy ratio, but there's probably not one developer who's managing 4 different microservices. It's a couple developers maybe know a couple of them or something like that. I read somewhere else like a service is a great responsibility. Like if you spin up a new service, you have to maintain it. You have to monitor it to make sure it's running still, update gems for security, and documentation. Like there's a lot that goes into a Rails app. Like when I was thinking about this fake llama app, even just breaking this apart, I was like, there's a lot of steps to like.
That's a lot of overhead.
Yeah. For sure.
Well, I think, and as you were describing before, just by having the discipline to keep things separate, you can get a lot of the separation in a monolith, where the lines are very clear. Oh yeah, this chunk of code does all of this thing, and it only ever talks to this chunk of code with very small limits.
Yeah.
But you don't have all the overhead of extra infrastructure,
Right.
other stuff,
Right.
and then you only add it in when you have a good reason.
Yeah, for sure.
And even if you stick with the monolith, you just have really well-defined interfaces that cross those boundaries. Those interfaces probably don't need to change very often.
Right.
Whereas behind them, a lot of change can happen. But
Yeah,
that
sure.
interface remains pretty consistent with the standard.
But the monolith doesn't force you to keep the discipline of boundaries. Yeah?
No.
Because if you have the boundaries, you don't have the information overload.
Right.
You have to coordinate between services. Yeah.
Yeah, part of the reason I created a new small fake app for this is many of the projects I worked on, like they're just, your typical Rails project is just a list of like 30 models and they all have relationships between them, and it's easy to get into that scenario because you start with a few models and you just sort of add and add and add, and they end up talking in different ways to each other, and then 2 to 3 years later, my boss was like, I would love to have these as different services. He didn't have a reason why, he just he wanted different services. But we're like, I don't know, like we haven't really thought about what are the domains and what are the boundaries, what do we need, but our app wasn't set up like that anyways. We just sort of went with the typical Rails approach of models which have relationships and whatnot, which is awesome. I would say in this, if you go with this approach within a domain or a module, however you code it, by all means, like relationships are fantastic. So within a domain, like don't be worried about using them. And another thing that may be good about this approach of modules is if you ever find yourself in this case, we're in the purchase module. If you ever find yourself writing a colon, that's like, I am crossing a boundary. Maybe I shouldn't be crossing this boundary. Like shipment, shipping, rates or whatever. Now I'm entering into the shipping territory. Maybe I shouldn't go directly in, but through some sort of intermediary gate. And that was the wall sort of example. Make it hard to cross from one side to the other.
So that's really interesting because then it also gives you a clear place to think on later on. Like if you want to sort of say, okay, do it to start with, but then if you've kind of said that's where we tend to make our boundary, it's something you can search for later to start cleaning that stuff out when you've discovered that the code base has lasted long enough that, okay, now we want to make it more maintainable, so we're going to start to eliminate all these things.
Yeah, for sure. And yeah, like say in this example, we made a mistake and for some reason this boundary didn't make sense. Maybe the order should have lived over on the, maybe a shipping domain wasn't the right sort of, it wasn't the domain that we should have come up with. I'd say it's a lot easier to reorganize our code. Because in this case I was storing the shipment ID and the order ID, they're already set up, like the data's right there and they could have a relationship, but it's sort of forcing yourself to not add that belongs to your model. And that's where the discipline comes in, I think. Because typically when I define a foreign key, the first thing I do is I like put the relationship in the model. Yeah, now they're connected. Yes. But maybe avoid it until you need it.
How do you normally handle things that do span across a lot of different boundaries? Like in this case, a customer that maybe is needed on an actual order page as well as the shipment tracking information as well as accounting versus wherever else.
I'll tell a story that is somewhat related. And I don't have like a perfect answer, I would say, from the get-go, but many years ago I created a website in MongoDB. And that was sort of the same problem we had in MongoDB, where we sort of had customers and orders, but because there's no joins in Mongo or like that type of database, we were like, hey, we've got an order, but how do we show the person's name who bought it? So we ended up copying the data over. But then the customer went and changed their name, and now we have one customer with two different names in the system. So we had to write code that when they changed their name, it would copy their name over to all of their orders. And it got messy super quickly. And then we rewrote it not in Mongo. But I would say there's a couple approaches. You can maybe copy over key information that's super common.
Thanks. There generally isn't that many.
No. But you do have to, maybe you're fine with them being out of sync. Like this was the name of the customer at the time they purchased this thing.
Right.
I'm not, like you sort of have a record of it at that, like an audit log sort of thing.
Mm-hmm.
Or you have to manage syncing it. Or you can have services that go both ways. So if you're on the shipping side and you need to access the name of the person who placed the order, you could have another service that goes, hey, because we sent references back and forth.
Yeah.
So there could be another interface that says, hey, can you fetch me the details for this order 1, 2, 3? And it would be another API call that sends it back. So, but then you've got two HTTP calls, so like, I don't know, you can't win in development, I guess.
I've seen that work really bad. When I started at East, they would have one microservice that you talk to. And so it would request from the other microservice for your profile information, your height, your weight, all that information.
Mm-hmm.
And then it would, that service had to talk to the original service to get all the clothing information, and then they did a sort and everything in memory because they couldn't do it in SQL. They had foreign keys into two different databases into each other.
Sort of avoiding the law of Demeter, but that almost made it impossible to. I would say there's other approaches too. Like this was very much synchronous communication. Sometimes communication between services will be asynchronous. So in that case, maybe you do make an HTTP request, but it sort of just saves it and processes it later. Or queue might be a good solution for that. To be honest, in Rails development, I love Sidekick. Like, for doing asynchronous stuff, you don't have to worry too much. It has access to your, like, the same app and whatnot. So that's what we use. We've relied a lot on for asynchronous stuff.
Yeah, we use pretty much everything.
Yeah, it's like the first.
It's really well.
Yeah. Yeah, it's pretty awesome. So I highly recommend that. Like, if say you're running a website and you need to send an email out, instead of sending it right then, you've got a couple choices to make. You can send it over to another service which will handle it asynchronously, or Sidekick, like for these types of things, are just like best solution, I think. Okay, we'll send the email, we'll respond back to the user, and then we'll send the email off in the queue later on. So I would say rely on that sort of stuff first before, oh, we need completely separate apps to handle this thing.
From your experience, did you notice performance gain when you break like a monolith trace app into microservices? Is it really noticeable?
So I would say I've never worked in a place with like tons and tons of microservices. Like most of the places I've worked with have had 2 or 3 apps rather than 15 or 20 of them. And I would say most of the communication handled was asynchronous between them. The sort of thing, like even if there were separate services, it would sort of make a request and then that app then posts like a callback approach, sends the information back to the original app. So in that sense, it was happening behind the scenes anyways. So, but it is something to think about, like by adding in network traffic and SSL handshakes and all of that stuff, what was a method call can add easily 30, 40, 50 milliseconds or more to your request. And if you've got a page request coming in and you want to respond, let's just say in 200 milliseconds or whatever, if you have to make 3 or 4 calls, you can quite easily blow past the amount of time that you want. So everything's I would say.
But you can scale that stuff up to be that performant. You know, Amazon's case. I mean,
Yeah.
Amazon's like the
Yeah.
user, they have like just hundreds of microservices. Services like each service is a team that is responsible for like language, environment, all those choices they make and are responsible for themselves. And they have SLAs for them that they have to respond to within a certain time frame, meeting certain conditions. But yeah, they just have enough of them in the scale that the pages are all super, super fast. Even though like an individual button might be like its own microservice. Like it's that level of separation.
Right. So they may actually be doing the call like from the browser to a different service rather than a back end reaching out to other services.
Send it all to one like server that just said, okay, I need to talk to like 50 different services to handle one request from you.
Yeah.
Blaziken is a good example, but that you get more infrastructure.
Yeah.
If you have that problem of you just got mentioned in the Washington
Right.
Post and everyone's come to your website,
Yeah.
that's awesome if you have that.
Yeah.
If you don't have that problem,
Yeah.
and if you paid a lot of, spend a lot of time doing the caches and whatnot, fast.
And even your example too, like if you're a small team and you don't have a lot of DevOps experience, like even if you have a lot of DevOps experience, it's still a lot of time. It's still a lot of time and effort to set those up and maintain them from the get-go. And I think the risk of making mistakes early on in that kind of a setup. It's a lot more expensive than doing it in a monolithic app.
Yeah.
It's really easy to recover from those mistakes, re-architect things. There's a lot less you can break and it can go wrong. But when you get to the point where if you need it, it's great to have that experience.
Yeah. I'd say like also, say you do need to talk to 3 or 4 services in one request. Depending on your language or setup, you could sort of make them all at once asynchronously and like a JavaScript promises sort of thing where make 4 requests and when we have the response from all 4, then send it back. Another,
The Amazon example, they
Yes.
use like a multi-curl complement page.
oh, cool. Yeah. Another technology that I'm pretty excited about is Elixir in general. I've never built real production apps, just sort of been playing around with it. But the way that it's set up is that it all lives on the Erlang virtual machine, this thing called Beam. And that virtual machine can handle all the communication between services essentially. So you're not having to make HTTP requests, it's sort of handling all of that for you. And the way you can set it up is you can build it all so that it lives on a single server and it communicates within that server. But if you do separate it out into multiple services or servers that live on like different IP addresses and whatnot, it's the Erlang virtual machine that handles communication between the services for you. So I think that's a pretty cool potential approach. It also has this idea of umbrella apps that are sort of apps which manage other apps, sort of like an umbrella sort of thing. Multiple apps live under the scope of one thing. And they can all live on one server, but you can also deploy them separately. And Erlang will handle all of the communication to one or more of sort of, it handles the like DNS, the round robin, like which am I going to send this request to? So I think that could be a good option if going forward. Sort of like once I have time, it's the thing I want to most invest in learning.
So do you know, can you actually handle like multiple Elixir services as a single code base?
Yes, it all lives in one code base, and it can all sort of be deployed as a single app. But it's sort of like multiple apps living in an app. So at some point, if you need to, you can say, deploy apps A and B to this server, and deploy app C to these 5 servers. And Erlang will handle how to communicate between them. So it seems like a really cool approach, but this is me just being excited, not with actual experience
It
about
does
it.
look really cool.
Yeah.
It does live code patching too, right? Like you can update a service without actually having to bring it down.
I've heard that, yeah.
And it's also Erlang has software threads. So you can have like 1 million threads in a single process and it's still super performant.
Okay, so what I hear is fine who's doing Elixir already in the region have presentations.
Probably, yeah. Well, because Phoenix is the like
That's the framework equivalent.
yeah, it's their big framework for new web development.
Yeah, for sure. Cool, well, I guess that's it. What happens next?
That's it for the presentation. You can stick around and chit chat until then the Old Maid crew kicks out. Thank you, Old Maid, for pizza and beer as always. And if anybody wants to chat about what kind of stuff you would like to work on next month, that would be a good thing to talk about. What projects feel like or what projects are you, or okay, is anybody already contributing to a project that they would like to help onboard other people? Yeah, see, I have the same problem. Because essentially everything I do is basically selfish. It's like, I want to make my projections. And I'm like, how can I trick other people into peer pressuring me into doing this?
Like we have a bunch of more sort of singular gems at Bullhead, but not really any that we actively contributed to for a long time. So like, fork this one, fix the couple of weird things, push it back, see what happens.
And help get it upstream.
Yeah, and then until the end user,
Any success on getting things upstream?
decent amount.
Depends on the repo though. If there's an active maintainer on the repo, then it's usually pretty easy. If it's something where like you see like 50 pull requests and the last one we heard was like 3 years ago,
It has also definitely happened that I've forked something, fixed a problem that I've had, and then realized there's at least one other fork that fixes exactly the same problem, if not like a couple.
And even that would be interesting, like if someone's fixed something in multiple forks, but just nobody's done it as a pull request, testing and documentation, whatever the maintainer needs to actually turn it, bring it upstream. That could be a good place to move things to. Well, would there be a gem that you guys would be interested in giving as a cause or
Potentially. The money gem is probably one of the ones that done the most work. We have a few patches of that.
Administrator's documentation. Administrator probably needs some
Oh, that's true, yeah. We have used administering a bunch, and yeah, the documentation of it is god awful.
It's okay if you don't do it.
Documentation's okay if you don't need the documentation.
Yeah, that's pretty much it. Yeah.
I actually had a gem I was using. Someone had like forked it to update a branch with Rails 5 support. Oh, great, good, I need that. So I put in that commit hash in my gem file, and they force updated their branch. After I put a comment in the original port request, we're like, hey, can we get this in? Like, I'm actually running this in production, and it seems fine. The guy's like, I've been using it in production for a year. I made some changes, but he force updated his branch, and then suddenly my deploy stopped working because I couldn't find that commit hash.
Sweet.
Well, in his branch, he forked off to do the Rails 5 support. This was like somebody who forked off his own branch in this gem to make a pull request from. Then he had force updated that branch, which I was referencing. Yeah, it was not a fun day.
Being able to reference Git repositories and gem files is one of those things that's nice to have. I was like,
Well, I thought it was
slightly dangerous.
I was being conservative, like I'll reference the commit hash because if he pushes new updates and breaks something, I don't want to get those. But no, it's a the branch. So that didn't happen again. Good times.
We've done also we have some commits into transitions, and he's actually pretty responsive to pull requests.
Everything I'm using right now is pretty much stable and fine.
That makes the root adoption. That's the next step.
Yeah, that's true.
Yeah, the gem is basically defined as documentation,
Yeah.
improving the code, removing the warnings. Well, or if you even figure the next step is like, if you have a gem that you use and you like it, and it works, so it basically doesn't need any work. What are the gems that it depends on?
Right.
More than likely, like something.
There's something else out there that needs some work.
Yeah, that's what I'm saying. PRs or whatever, these things that can be just commented on, say, this works, this doesn't work.
Right.
This is old and no longer relevant.
There is a project called Refactor Cop as well, the one that Rails Rumble 3 years ago. And it runs Google Cop on open source Ruby projects. And then,
Ooh, that sounds familiar.
yeah,
Are they still running?
they are still running. Let's check to see if it actually still exists, and it does.
Isn't there a website, some like medical term, triage, or code triage or something like that?
There might be that too.
And it basically shows you issues with open source.
Yeah, I think I was on that like 3 or 4 years ago, and I couldn't find the information to actually follow any of the emails, so I stopped it. Yeah, I think they sent you an email that was like 1 or 2 open issues on some project. Yeah, I think with the idea that you go and help to improve them in some way.
They have a bunch of popular projects listed on their site in descending order with number of issues. Number 1 is Kubernetes with 4,500 issues. things like Rust with 2800 issues, Go with 2600, NPM 2400, Docker 1900. There's a lot.
Can you filter by language?
Yeah. Let's find out what Ruby is.
Docker, only 1900.
Rails has 1100 issue. Travis has 1100. Chef is the first yellow one. The others were all red. Chef is a yellow one with 500 issues. Vagrant has 400 issues. Heroku has 300 issues. That's the Heroku client.
The client has 300 issues?
I mean, that's pretty low for a project that big.
Those are Josh mentioned, Administrate. They're great. And they have 143 open issues currently.
And it's fairly early in its project.
Yeah, it is.
What does administrate do?
It's basically like ActiveMin or Railsmin or some other version, some automatically generated administration build. The biggest benefit of them is it's not some weirdo DSL. It actually generates real controllers, real models, real all of the things. So it's much friendlier to actually edit if you're used to Rails.
Sounds cool. I hate that acronym.
Right? Yeah, it seems neat for like the first half hour or so. Progress that I do.
Yeah.
Yeah. And then you're like, oh no.
Anytime you have to do something weird, you need to learn this whole DSL of like how
It gets complicated fast. The administrator is basic. It's by ThoughtBot. So it's basically generate things. It gives you a couple of dashboard classes, and then all of the each field has a data type. You have some special data type. You just define a new class with that data type's name, and pretty much only define a two-string, and maybe a couple of other things if you really need it. And then you can generate controllers and use all of the stuff that it actually uses by default. So it's really nice.
Does it update the generated classes if you make changes to the backing models?
Not
So you have to maintain that yourself. Yeah, I guess if you already have examples, it's pretty true to do that.
Yeah.
That's good.
It's pretty common that you don't want everything in your dashboard anyways. So it's just an array of symbols, and then you add symbols as you need to, or remove them more commonly. Sure. It's really good.
You get some trust in
It's very, very nice for what it does.
Yeah. I mean, you were talking about like web testing, I would just web mock, which is what I thought about as well, which is like a lot more lightweight than VCR. It's not as automated where you can actually make requests and store the response.
Yep.
It's pretty simple.
Like that.
Yeah, well,
Anyways.
well, if you have to do like sanitization, it's gonna work, but you do get more realistic data representation, like actually real headers from a real server,
Right.
right? Like whereas with WebMock, if you don't actually include those headers, all you're really subbing is like a response status and like the login, which for most things is usually fine.
Yeah. Well, yeah. I'd rather like I don't know. I've always known that I prefer the mock approach with an integration thing for like going across boundaries. 'Cause it's slow to have HTTP, and like if you're doing VCR, you get it real once,
You could
and then
automate
it's
that,
not.
though. You could automate it like weekly or monthly, like hey, do VCR run, and
Yeah.
if you have to do sanitization, you can be like, this is the stuff we're sanitizing these responses, and you can have the sanitization pass be like, hey, I couldn't sanitize the things you told me to. You need to take a look at this and update your automation code. You could do something like that, which would actually take care of the like, because with WebMox you still have the same problem. Like, hey, the actual real responses have changed, but you're using your box and it's fine. But in reality, your code's breaking.
Which actually, I've never seen anybody come up with a standard solution to that, which would be kind of interesting. Because yeah, I mean, it's exactly that is almost a, if you're doing a web mock or VCR, it's something you should be doing in
Yeah.
some way, whether it's manual or
Yeah,
automated.
you have to maintain that.
But if we're actually able to describe a framework of this just how does this, it automatically goes to your webhook stuff, or your VCR stuff, and then does the right thing once a week to check.
You almost need like a combination of things, like actually do a VCR request to look at the response, and if the webhook, test needs to update, include the data of that or something.
You could also go the approach kind of how, which doesn't work, is it might be our spec plus any test where like if you are using mocks, it will tell you if your mocks don't match up with your model interface.
Right.
And so you can still have mocks, but there's also like a secondary, like a single check that does like do your mocks fuzzily match with a real request, and so you do that once to verify that it's still a valid mock, and then you do everything else against the mock.
So it also depends on how much you actually trust the service.
Yeah.
Because if you like 100% trust the service, like they can manage their shit, they're gonna version it, they can do all the stuff, then you mock it once and it's mostly should be fine.
Right.
And if it's not, that's kind of someone else's fault.
Yeah.
Yeah.
If the request has like a V1 in it, you're probably okay.
Should be
Yeah.
For the most part.
Yeah. And if not, then it's probably easier to still continue to mock it, but then also do some sort of other thing. Like, is this request still looking mostly like what we expect?
Yeah.
And I feel like if you're going the like multi-service approach, you should be thinking about it that way, where it's like, no, I should trust that the service is going to do what it's supposed to.
Probably.
Because like, why is this app over here concerned with like what your thing over there is doing? Because if it's concerned with it, then why is it a separate service?
Yeah.
So, I don't know.
Then you end up having to test that exact same service in your 6 other apps that actually depend
Yeah.
on it,
Right.
and it ends up giving us all a lot of work.
More reasons why microservices are painful.
Well, I guess what you were describing, the thing you guys haven't done yet is the the single vagrant file or the single Docker file.
Yeah, they had that at the score. And I didn't even really know what it had in it. It just sort of did stuff for me. And they had like a vagrant update task that every couple days or something like that, they would actually save like a real copy of the production database. It's just sports stuff, so it's not like sensitive user information.
Right.
And so like every couple days you could update your local database vagrant with the like real production data. So that was pretty cool. Like everyone basically was running production on the local setup.
That's pretty good.
But they also had like 3 or 4 DevOps people. So like there were people that were actively making sure those work and whatnot. It wasn't just like some developers a couple hours a week thing. I think at any point, once you start getting up to a scale where you've got a team that does stuff for the rest of your programmers, that's when you start to get to be able to do stuff like that.
Which I guess is kind of the Conway's law. Your program fits the structure of your organization. So
Right.
before you're big enough to actually split into multiple teams, it sort of makes sense that your program is just one thing. But as you start to split into multiple teams, it makes a lot of sense that it starts to become multiple things.
Yeah, because I have heard Google stores everything in a single code base, which is insane. But I mean, I guess they have the people to manage that sort of thing. But I think for like an Amazon, they could never run like a monolith Rails app for.
Apparently, Facebook supposedly is the same thing. They've got one enormous data repository.
Yeah, Google and Facebook both have it all in one repo. The Google one's especially crazy because it's actually a fork of Perforce. Because actual Perforce won't run with the amount of code that they have in it. So they have tens of engineers actually maintaining this version of Perforce that was forked like 8 years ago.
I think I read there's like 10,000 commits a day
It's crazy.
between humans and bots like updating their code for them.
And then Facebook's the same sort of idea, where they have, it's all in one repo, and I was wanting to talk with, there's one of their directors of engineering or something like that a little while ago, and basically coming up with the justification of why that's useful for them. And it's basically dropping a field from an API sort of thing, where as long as everything's in one repo, everybody knows where everything is, and if you're running this service over here, you know everything else, or can at least find all of the other pieces of code that depend on it. So then when you actually do drop or deprecate something, it's your responsibility to go out and make sure that each of these individual things still are green and still are okay, and if not, tell the team or drop it yourself. So there's a lot of tools around actual code introspection and finding dependencies.
Yeah, I guess when you're big enough and you can throw resources at managing that, you can do it, but every time I hear it described, it sounds slightly crazy.
Or you just make your own languages. Like, we're in PHP, but we don't like it, so we're going to invent our own high-level interpreter. Anytime you can just invent your own language, you have different issues than.
Yeah. You're creating your own language, right? You have different things that you care about.
Well, let's invent our own JavaScript framework because we don't like what's out there.
Weird checks that I found is Opal.
Oh yeah. Never used it, but
Looks interesting. Transpiles Ruby into JavaScript, right? And the weird one built on that would be React Ruby. So you're writing React and Ruby.
there's so many levels between what you're doing and what the browser actually does.
I mean, that's true of every programming.
I guess that's true.
Yeah, that's true.